Thanks for watching.
In this video, you'll learn about a common reaction type called a double replacement reaction.
So far in this video series, we've seen 3 other reaction types: synthesis, decomposition, and single replacement. In this video, of course, we'll add a 4th called double replacement reactions. In a double replacement reaction, you'll see cations, or depending on how you look at it, could be from the perspective of the anions too, but we'll stick with cations. From 2 separate compounds will trade places and replace each other. The general formula for this looks like AY plus BX turns into AX plus BY. You can see that the A and the B essentially trade places, and you get A that's now with X and B that's now with Y. For example, if you had KCl reacting with AgNO3, the 2 cations written first, K and Ag, will trade places with each other, and you'll get Ag that's now with Cl and K that's now with NO3. In our dancing analogy, we'll begin with 2 sets of couples. Brown shirt will trade places with red dress, so now red dress is dancing with pink shirt, and brown shirt is dancing with orange shirt. For some real examples, you've already seen potassium and silver switching with KCl and AgNO3. Here's another one where cobalt trades places with sodium, so the cobalt is now with SO4 and the sodium is now with chloride. Let's wrap it up by looking at a couple specific examples. Here, calcium chloride is going to react with aluminum fluoride. We're going to focus on the cations written first, calcium and aluminum, as the elements that trade places. So let's start with calcium replacing the aluminum. So I'm going to get Ca that is now paired up with F to make a new substance. My aluminum is going to come over here and replace the calcium. So in my second product, I'm going to have the aluminum that is now paired up with Cl. To write these new product formulas properly, remember that we have to check the charges on each element. Calcium is a +2, fluoride's a -1, CaF2 is the proper formula. Same thing with aluminum chloride. Al is a +3, Cl is a -1, AlCl3, making my 2 products CaF2 and AlCl3. Let's look at another example with calcium carbonate reacting with aluminum phosphate. Now we have some polyatomic ions, so a little bit more to pay attention to. Process is the same though. My 2 cations, calcium and aluminum, again are going to trade places. So calcium comes over here and kicks out aluminum. So now Ca is paired up with PO4 to make one of our products. The aluminum is going to trade places and kick out the calcium. So in my second product, Al, aluminum, is now paired up with CO3, my carbonate. Just like in the last example, let's check the charges on these ions. Calcium is a +2, phosphate is a -3. So my formula has to be 3 calciums, Ca3, and 2 phosphates, PO4, 2. Remember with polyatomic ions, when you need multiples to put parentheses around the entire formula, Ca3, PO4, 2. Again, with aluminum carbonate, Al is a +3, carbonate CO3 is a -2. So my formula will have to have 2 aluminums, Al2, and 3 carbonates, CO3, 3. Again, parentheses around the polyatomic, so we know that there's 3 carbonates. That concludes this video on double replacement reactions. Here's a brief summary.